Um, and until then, I can sort of
Yep.
begin. Me and Denise will do a presentation together. I will start speaking about a real incident where we use Timesketch and the benefits, how that worked, and then Denise will walk you through how we made the integration together with Timesketch and all the lessons learned from that part. Um, you're all able to see my presentation, I hope.
Yes, we can see the slides and we can hear you well. So
Good.
stage is yours.
Alrighty. So I'm not going to explain who CSIS is, but I can tell you that I joined the company like 11 years ago, and at that point I was doing a lot of forensics investigation for a bank, and had my courses with Rob Lee from SANS, and I got inspired about that at that time they were missing a collector that could collect data and remotely like send it a place where it could be analyzed. And that was extremely interesting because in CSIS, one of the things we were doing was helping banks across the world to investigate fraud cases. So very often we would have to collect data from one of their customers, which could be in Brazil or Argentina or the US or anywhere in the world. And in the beginning, we were using kind of a USB and a CD-ROM to collect the data, and it was a big mess. So the first thing I did was actually building this data collector that would collect the data. And then I learned about Log2Timeline and Plaso at my forensics course, and we kind of combined that as a service. And that is actually what we have been expanding on the last couple of years. When we're speaking incident response, we have kind of define different tracks in the way we do it. So there is the first track, which kind of is the attack identification that's typical happen with the customer of ours. Then you have a containment phase where you kind of stop the bleeding. You have an extent of damage where you do the full analysis. You also want to find out the patient zero, how the customer got in or how the fraudsters came in. Then you have a recovery phase, and you want to know who's behind the attack, and there's a communication phase, and then at the end, a reporting phase. The reason for showing this is that we found Timesketch very, very useful in the extent of damage, uh, understanding the patient zero, and then at the end with the reporting. These are the three areas where we are integrating with Timesketch for our incident response processes. So firstly, I'm going to go you through a case study and highlighting the interesting parts. There's something not related to Timesketch, but for the storytelling, I will kind of touch upon the different tracks. So, not very seldom, ransomware is a big thing we're investigating, especially the targeted ones. And in this case, the customer identified that they were compromised because 160 virtual servers were down and couldn't start, and they represent the most critical business applications. Their backup system was destroyed, so it wasn't possible to recover from backup. The containment phase, stopping the bleeding, there were key personnel that did some really awesome actions. They blocked the compromised account that was used to kind of shut down the environment. They took the internet connection away. They contacted the CIO, and then CSIS was involved. So that was basically up to the whole thing. Then we start typical the tracks in parallel, and there are also sub tracks under each of them. So the extent of damage, kind of the first part whenever we come to a case like this, is we have built our own data collector, as I talked about in the beginning. And it's something that runs on Windows, Android devices, and because they are the primary thing we see. So we basically start deploying that, collecting, in this case, artifacts from 550 devices. And because of our knowledge from Plaso and Log2Timeline and knowledge in forensics, the way we collect the data is by their raw format. So reading to disk using a sleuthkit, and basically reading out all the files, the raw files, because that allows us to use standard tools, which became extremely really important for us in our work later on. So in this case, we have whenever the data is being collected by our tool, we have some automated analysis that helps us finding different things on the systems. And in this case, obviously, whenever you have so many machines, you really want to have something to look for. Even though you have a great master timeline, you can search across all your systems, you still want to find these different indicators that can help you kind of zoom in on the events. So the first part here was basically to start with what we knew. So we knew that somebody logged into the virtual environment, and we could see in the logs by manually investigating that it came from an IP address of one of their DMZ servers. So we started, of course, to deploy our data collector on this system. And what we found there was that it had what we call a Tor backdoor, so a reverse backdoor that would connect out on a Tor onion link, and then the criminal could basically sit from anywhere in the world and connect into this machine over RDP using an onion link. We also realized that there were 10 Linux servers that was installed on the virtual environment by the fraudster or by the criminals. It was called something like restore_xx VMDK. So just to see, in our automated analysis, we identified the Tor backdoor on the system. We identified a port scanner that was being used as well. And that basically gave us at least 2 indicators. There were several other indicators. I'm not going to go through all of them. But then we had something which we could then start looking for in the big timeline in Timesketch. So the reason also to mentioning, what was the reason why we couldn't just use our own tools? Well, our tools was built as a one-to-one analysis. So typical when you had a fraud case in the banks, there would be one device in question, or sometimes 2 or 3. But that meant that the whole terminology we had built around it was that you get one machine in, you investigate that, and you move to the next one. But obviously, when you do incident response, you have so many machines, and it doesn't work with that. So instead of building our own system, we found Timesketch to be extremely interesting for exactly the things we wanted to do. Just moving on, so the part 2 of the investigation was, of course, then fire up Timesketch, import the 550 cases into Timesketch, and then start looking for the different things we already found and knew, and a lot of other artifacts. Using Timesketch, we were able to identify multiple servers that were compromised and had this Tor backdoor installed. Several user accounts and service accounts and domain admin accounts were compromised. There were several hacker tools discovered. We found the ransomware node that was actually pretty well hidden in this case on an old legacy server, and only placed on one server, not on every server as you normally see. There were no evidence of data being stolen from the customer, and the first malicious activity started 3 months prior to the attack. All that we were capable of detecting by using Timesketch once we had all the data collected. The patient 0 is, of course, also part of the extended of the investigation, and in this case, again, using Timesketch, because we look for kind of normal ways of breaking in. So one of the things we looked for in Timesketch was the proc dump tool, which would dump the memory of the machine, and then they could basically read username and passwords. And there was an event on one of the machines we collected data from, which basically helped us to identify that the attackers came in on a server that was put up because of COVID-19. They had to put up a VPN very fast, and they put it up on the internal network, and that was open for RDP, which was then brute forced, and they got in doing that. And the first activities basically happened on this machine. From that server on, they moved on, and as I said, they were in the network for 3 months doing a lot of different malicious activities, and the amount of accounts they compromised and used for different purposes was enormous, and would basically have been impossible for us if we did not have a centralized system to search in. Oh, well, I'm also going to just give you an info about the recovery phase, because this was, as I said in the beginning, the backup was destroyed. So the customer wanted to find a way to kind of recover. So one thing to do here was, first of all, identify and prioritize the most critical system to focus on. Send the destroyed backup system to the customer backup supplier. They came back, said, we cannot do anything in this regard. Then we started off a track about communicating with the attacker. They initially didn't reply back, so we thought that it might be sabotage and not really ransomware attacks. And that left us with one option, and that was to basically decrypt whatever they encrypted. And that was a really nice finding. Now you guys, all incident responders on this call, I guess most of you are. And we found out in this specific case that the attacker, he used those Ubuntu servers that was installed in virtual environment, shut down the normal servers, remounted their disk in the Linux system, and he did an override of the first 240 megabyte just using DD and random data. And then he left that data block on the original data block on the Linux servers in the environment. And basically the ransom was about giving us back the access to the Ubuntu servers and then basically DD back the data block that was encrypted. So a very, very different technique, not using standard ransomware at all in this case. And that left us with one of the other attacks about who could be behind the attack, because was it sabotage or was it really extortion, as we couldn't get in contact with them. We got in contact with them. They replied back after 5 days, and they said basically that the email we sent to reach out to them had been taken by their spam filter. We could see from the webmail account they created that one of them was native Russian or had a Russian language keyboard installed, and one was from the US. And they, unfortunately for them, they left their browser portable version of Firefox on one of the machines that had a lot of interesting information about who these attacker was. So we kind of know who they were, because PayPal accounts, webmail systems, webmail emails they were using, online shopping, phone numbers, etc., was in the browser history. They couldn't get Flash to work from the servers when they wanted to access the virtual environment, and that's where they kind of copied over their Firefox portable version that could help them, and forgot to delete it again. The attacker didn't contain any fingerprints that pointed to a known ransomware group in this example. Then there was a communication track, and I'm not going to bore you with that, but in general, I would also say that Timesketch can be used in this area, because a lot of the times people want information instantly across multiple servers that used in presentations. But in general, communication path is more about speaking with the police, speaking with GDPR concerns people, speaking with the IT criminals. We have a full department for that. Internal and external communication is extremely important as well for us to cover. And then the reporting part. There is Timesketch also really, really useful, because whenever you find these indicators around and you want to build your report afterwards, it's so nice that you can tag the different findings and export that to a report. And some of the things we typically do when we come in is some immediate actions, so hardening the stuff so it doesn't happen again while we are doing the investigation. And then there are, of course, future recommendations that we often goes in. But what I want to mention here is that Timesketch here is extremely useful to help you build your report at the end of the investigation. So just to give a executive summary here, in this incident response case, the attacker's motivation was opportunistic. They came from Russia. They were medium, but very unexperienced, at least in extortion. It was a targeted attack, definitely, but not to begin with. It was a random brute force that gave them access, and then it turned into a targeted attack. Was the known hacker group? No. They were in 3 months' time. It was detected because the server stopped responding. Nobody actually found the security events that was visible there, but nobody was monitoring them. So could it have been detected earlier? It definitely could. GDPR data wasn't leaked from the network, so no GDPR concerns. Was the customer's IT security prevention worse than similar companies? And this was a Danish company. I would say no, but it doesn't mean that it was good. It's just that the barrier of security in Danish companies are in general not that great. How did the customer handle the incident? Excellent. So I just wanted to set the scene about how we're using it in real case, and then now Denise, he will take over and he will show you how we actually do it, combining a more commercial product like our forensics tool Circ with Timesketch. So the word is over to you, Denise. I will stop sharing my screen and you can take over. And while we're doing that, I will be open for questions, of course, if you have any at this time. Otherwise, we can wait to the end.
All right, thank you. Yeah, I hope I'm sharing my screen. Yes, so first of all, some numbers in order to give an idea of what we had to deal with in this case. So on average, we are extracting 7 million events from a device. And in this case, there were approximately 550 devices. So in total, we had 3,850,000,000 events to process. And yeah, that just looked difficult for us. Of course, this many events consume a lot of storage space that will take time to transfer, to parse. And it seemed a tough task in general. Yeah, so on the next couple of slides, we will show how Timesketch helped us to handle this amount of data. First, I'm going to show quickly how our remote incident response kit works. And then I will talk a little bit about requirements for integrating a third-party product like Timesketch. We will also share some ideas on configuring Elasticsearch for best performance. And I will also show a possible workflow for importing data combined with third-party data to Timesketch. Yes, our architecture is a quite ordinary architecture, I guess, in terms of incident response. We have the collectors that collect the data from the devices like a Windows computer or even Android, if needed, and then they encrypt the data and upload it to the cloud. Our backend then fetches the data from the cloud and analyzes it using our own threat intelligence, and then it creates a report that is shown on our portal for our customers. And also, in the meantime, we can create master timelines from some of that collected data that we can use in order to verify the IOCs or possibly discover new IOCs. We are using Plaso for that. As Jan already said, there is some inherent limitation in this architecture, though, that one report belongs to one device. So it's really not straightforward to search in several reports at once. And then we found out that Timesketch exists, and that Timesketch could help us to search in multiple devices at the same time. And also, it is really fast. We saw that already at the first time when we tried it. And also, we noticed the analyzers that could help in automating some of the time-consuming incident response tasks. And actually, last spring, we already made one analyzer for safe browsing that checks the URLs from the events against safe browsing. So a decision has been made to integrate Timesketch with our systems. Our basic requirement is high uptime because we are working literally 24/7. There is always someone ready to handle a case. And of course, they must be able to use Timesketch in any time, over the weekends or in the night shift or whatever. And also, ideally, the setup should be scalable. Sometimes we have cases like this with more than 500 devices. Sometimes we only have a couple of cases to look at. So we just don't want to waste any resources on keeping up a huge cluster if it's not needed. From an operations viewpoint, we had to set up monitoring, logging. Just we can see what goes on and monitor the whole system. We also have quite a few users, so we need to be able to manage them. What we needed to do is to integrate it with our own Active Directory, so we can precisely see who can access Timesketch and who can access the data through Timesketch. And also we need to make regular backups of the database that's used by Timesketch in case of anything happens. Development-wise, we had to make sure that our data that we are exporting from our system is compatible with Timesketch. That boils down basically to those 3 mandatory fields. So we need to have that for each event, obviously. And also we had to make some interfaces to connect to Timesketch through the API client, so we can see a list of sketches or basically anything we can access in Timesketch and work with it. For a use case like basically high performance search, it is also crucial to set up Elasticsearch the best way it's possible. We decided to use a certain external provider to use Elasticsearch. It's hosted in the cloud, and we hope that will let us to focus on using Elasticsearch instead of maintaining it. It also makes the deployment easily scalable. We can choose a bigger cluster anytime, or we can reduce the size of the cluster anytime it's needed. And also there is a dashboard where we can just have an overview of the cluster's performance and we can see what is going on anytime. So what I will talk about next is basically how to fine-tune Elasticsearch, at least how we fine-tuned Elasticsearch in our case. But to begin with, I think it's a good idea to use a reverse proxy to access at least an externally hosted Elasticsearch instance. Then Timesketch can see a huge local cluster at the default address. That's the basic setting, that's the default setting. And we can change everything else in nginx. And yeah, that's just very, very flexible to do it that way. It is also important to prepare the data, so it's easier to handle, and we put a lot of efforts into removing unnecessary fields, for example. There are some examples on the slide, we found that some filename fields are not always necessary for a certain IOC because it was pointing at a temporary file whatsoever, so it's not relevant. Or for a large unique file, maybe it's not needed to have the MD5 hash. And taking all of these fields out of the data we used, we could always reduce the size of the timeline by at least 10%. And yeah, I mean, of course, less data is the better. It takes less time to index, and that's why it's needed. All right, so talking about Elasticsearch, our first try was to optimize the size of the bulk requests that Timesketch is doing. It's basically the number specifying how many actions are performed per request on the Elasticsearch cluster. I think the default value is 1000 now. What we suggest is increasing this default value, meanwhile watching the indexing speed on the dashboard of the Elasticsearch provider. And when it reaches a constant value, that's the optimal speed, and that gives the optimal performance. It always depends on the setup and the actual provider. So I don't think there is a better default value than 1000, but it's definitely worth to have a look at. Elasticsearch is also more than happy to handle multiple requests at the same time. It will ingest the data much faster. So what we are doing is when we get our final timeline in JSON-L format, we split it up to parts, like a couple of thousand lines each, and we have 32 workers uploading these chunks at the same time. And is just much faster. And our final advice is disabling refreshing indices before ingesting. So by default, Elasticsearch refreshes the indices, I think, in each second. But for a use case like our, it's not really necessary, because we don't want to do searches anyway, as long as the timeline is not in a Timesketch. So when we create the new timeline, then we just set this parameter to -1, that disables it, and when we are done with the upload, after the last part, we can just change it back to the default value or any other. This also speeds up the whole process, and at this point, the average timeline I mentioned at the beginning with the 7 million entries can be uploaded to Timesketch in 30 minutes, which was much better than our initial results that we got. Yes, an interesting fact that we were also counting on that we need to implement a feature to scale the Elasticsearch cluster according to our data needs continuously. But in the meantime, we just realized that our provider added that as a feature. So it's just one click to enable that on the dashboard, and probably that solved all our issues we expected on that end. Okay, so this is a possible data import workflow. It's what we implemented. It's a bit simplified here. The first step I call shipping. That can be started from a simple in-house web interface, and the process can be started there, which downloads the data from the various places. And after it gets to the second step, that's called enriching. First of all, we add some events related to our own tool to the timeline, like when a certain collection was started, exit codes of the tools, and stuff like that. So it's just visible for the investigators what happened, and I mean what we think what happened. And also we correlate our own threat intel to any sort of event that's present in the timeline. So we look through the domains, the IPs, the hashes of the files, and for example, if there is a hash belonging to a file, and we know that file, as the example shows down here, we can tag it as good. And also there is a trust factor like good, trust, medium. And then this works with any kind of threat intel we have. So it really adds value to the data at this point. We also add another tag. It's also visible here if we collected a sample. So then the investigator can know that we have the file itself. So if they need to reverse it, or they just want to have a look at it, they can look at the file elsewhere and continue their investigation. Yeah, the last two steps is really just normalizing the data. So there we are removing the unnecessary fields. As I mentioned it before, that's done into this step. And then we are merging the files, and in the very last step, now we are splitting it up for the more workers, and we added it to a new timeline using a TSCTL. Okay, so wrapping up all of this, what we recommend if you are integrating Timesketch to your workflow is, first of all, to clean up your data. It takes time to handle data, and we know that time is money, and it really doesn't make sense to upload sort of everything to Elasticsearch, because it needs to be indexed, it needs to be transferred. It should be looked at before. We really recommend that. Also, it's important to enrich the data before importing to Timesketch, because we want Timesketch to be the only place where the investigator is looking at the timeline. So ideally, everything will be visible there on their screen. And we really recommend to try to correlate and connect events together before. When testing and setting up the system, we also recommend collecting metrics of the system, performance metrics like basically anything like memory usage, per process, Elasticsearch metrics. It will really help a lot when fine-tuning Elasticsearch, as I showed it before. And remember that this is a highly iterative process, so it must be repeated several times. I'm sure I had a couple of test timelines. I don't think I uploaded them less than 100 times when I was setting this up. And there was always something in the configuration that could be tweaked a little bit. It really pays off in the end. And lastly, we think that as a developer, I think that it really helps to settle on a specific Timesketch release when you are working at it. Our system now uses the release from the 20th of November. And even though I saw all those new features coming, because the code base evolves really fast, it helped me a bit to sort of limit my scope to one specific release and not to overwhelm the whole process with everything, which also means like soon we can start updating it to the newest release to have all the new features. That was